Right, based on what you have learned in additional mathematics at the O level, you have came across questions involving the concept of finding the area of the region bounded by a curve and the lines parallel to the coordinate axis. But what you have not learned is the concept of finding the area of the region between a curve and an oblique line, or between two curves. So let's revisit example 8 to look at this concept before discussing on what you have not learned before in O level. Okay, for example 8, we are told to find the area bounded by the y-axis, the curve y equals to e to the power of x, and the line y equals to 4. And we have discussed about method 1 on finding the area by integrating with respect to y. And method 2, which is using the area of rectangle a plus b minus away the region b, will allow us to get the required area a. So now there's another method to deal with this problem here. To find this area A, shaded in yellow, what we can do is we treat this line y equals 4 as the upper curve, and this curve y equals to e to the power of x as the lower curve. So based on your O-level knowledge, so let's call this method 3. Okay, based on your knowledge from O-level, you know that actually the area of A can be found by integrating from 0 to ln of 4 the upper curve, which is y equals 4, minus the lower curve y equals to e to the power of x dx. So essentially what you're doing here is you find the area under the line y equals to 4 from x equals 0 to x equals to ln 4, which is this whole thing here, the blue box. Minus away the area under the graph y equals to e to the power of x from x equals 0 to x equals to ln 4, which is the pink shaded portion. So therefore, by evaluating this integral, we should get the answer. So let's try working this out. So integrating allows us to get 4x minus e to the power of x, upper limit ln of 4, lower limit 0. And doing some calculation, we should get 4 ln 4 minus e to the power of ln 4. That's when I sub in ln of 4 into this expression here. Minus away the case where 4 times 0 is 0, minus e to the power of 0. So it turns out that I will have 4 ln 4 minus e to the power of ln 4 is actually 4. And minus negative e to the power of 0 is 1, so I have a plus 1. So it turns out that I will have 4 ln 4 minus 3. And since 4 ln 4 is actually 8 ln 2, when you simplify, you essentially get back this answer, 8 ln 2 minus 3. Right, I hope the earlier discussion on example 8 method 3 allows you to refresh your memory on what you have learned in O-level. Now flip back a few pages to look at example 6. Right, example 6 says this: find the exact area bounded by the curve y equals to x squared minus 1 and the line y equals to negative x plus 5. So which area we are talking about? Essentially we are talking about this particular area bounded by the two graphs. Take note that this is not what you have learned in O-level, because we are looking at this line. This is actually an oblique line. So how do we go about finding this area? Recall what you have learned. You need to integrate from the lower limit to the upper limit of the upper curve minus away the lower curve, where the upper curve is this line and the lower curve is this graph. So what is the lower limit and the upper limit? Based on the graph, we can clearly see that lower limit has to be -3, upper limit has to be 2. How do we find the lower limit? We find the intersection point, the x-coordinate of this intersection point, and the upper limit, the x-coordinate of this next intersection point. Right, so the area will be integral from -3 to 2, upper graph -x plus 5 minus that of the lower graph. So this gives us from -3 to 2, -x squared minus x plus 6, which is what you see right here. Okay, you can choose to integrate manually since this is not that difficult to actually integrate. What you arrive is this, and again substituting 2 into this expression, minus away that when it is -3 into this expression here, you get this, and finally arriving at this final answer. Okay, take note that the question asks for exact area bounded by the two curves. So we leave our answer in fraction. Alright, so alternatively, you can actually use your GC to find out what is the area between the two curves. Alright, let's go to our GC. Okay, suppose that earlier you already key in the equation of two graphs, and in my case, x squared minus 1 is this graph, and y2 equals to -x plus 5 is this oblique line here. So for GC there are some limitations. It does not allow me to actually find the area of the bounded region here. So let us see. If I calculate the integral, let's press number 7. Lower limit we know is -3. Upper limit we know is a 2. You see, this does not give me the area that I want. In fact, I'm interested in finding this area here. So what I'm going to do now is, let's quit this page. We go on to use this. Press alpha window. Number 4. Function integration. Lower limit -3, upper limit 2. Of which function? Okay, it's y2 minus y1, because y2 we define it as the oblique line and y1 is actually the curve. So in this case, how do I call out y2 and y1? Let's go to alpha trace. y2, enter, minus away y1, again alpha trace, enter. Differentiate with respect to, because y2 and y1 is written in terms of x, so this has to be x. So enter. So this gives us a non-exact value, 20.83333. To convert to a fraction form, let's go to math, press number 1, and enter. This gives us 125 divided by 6, which is the exact value.